Okay, hi everyone. I'm Zdenek, CTO at Codasip, and today I'm going to talk about some challenges and the opportunities or hopes or wishes or promises about the open hardware, open source hardware. It's kind of my point of view. It doesn't have to be necessarily Codasip's point of view. But before I dive into this, let me just introduce our company, who we are, what we do, and what we offer. So, Codasip is a provider of RISC-V compliant IP. So we have a family of RISC-V IPs, and I have a slide on that later on. We are a founding member of RISC-V Foundation, so we are there for a really early beginning. The company itself was founded in 2014 in the Czech Republic, and recently we opened offices in China, in Silicon Valley, in Germany as well. The technology itself is based technology is based on the research that's was running more than 10 years already. So although the company was founded in 2014, the technology is definitely older. Well, if you look at the family of RISC-V IPs, the family itself is called Berkelium as a tribute to guys from Berkeley who came up with RISC-V in the first place. So what we have is three series. It's called BK3, BK5, and BK7. All of them are fully configurable. It means that you can enable or disable certain RISC-V ISA modules. So for those of you who are not familiar with RISC-V ISA is designed in a way that the mandatory part is about 40 instructions, and then you may add things like multiplication, compact instructions, or floats, or atomic operations and maybe manipulations. And thanks to our technology, you can really pick and choose whatever you want. So you can configure the RISC-V course in really, as you want. But and the configurations that we offer are fully verified. So we run a UVM-based test bench on that. We have coverage reports, verification plans, everything. So that's part of the jobs that we do for you. And the thing is that we don't stop you there. If you need something else, if you need some kind of differentiation or innovation, then we allow you to do customization. And we do it by DDA tool that I will talk about later on as well. All cores can be configured also on the microarchitecture level, so we can enable, disable debug, interrupt controllers, caches, and these kind of things. So if you look at the cores in more details, you can see BK3, 5, 7. So BK3 is 32-bit, 3-stage machine that can be configured, as I mentioned. The BK5 can be 32 or 64, again configurable in several ways. The same goes with BK7. BK7 is 64-bit Linux-capable core with all the stuff that Linux needs to have, like MMUs and TLBs and these kind of things. So we cover quite a range of performance or power requirements from very small MCUs up to cores that are able to run on Linux. If you look at the configuration and customization, for some people it's kind of synonyms. In the Codasip world, it means different things, because by the configuration we understand, again, choosing from the ISA modules that are already defined or ratified by the foundation, which is this part. So you can pick and choose whatever you want. Obviously, there are some combinations that are quite common, like RV32 IMC. This is quite common. So yeah, this is something that we have as well. You can configure the microarchitecture options. So again, the caches, debug, things like that. So you can configure a core in a way that contains exactly what you need. And in some cases, or in a few cases, it's just enough, or maybe in many cases, it's just enough of what you need, and just license this core and that's it. But we have customers that say, okay, this is nice, but I have some audio algorithm, some codec that I need to accelerate, but the current ISA is not powerful enough. So what I can do? And our answer to this question is, okay, just use Codasip Studio that we provide. Codasip Studio is a tool by which you can do that and add your key differentiation or innovation to the product that you are developing. So if you talk about the studio, so what's Studio? Well, it's an EDA tool by which you can configure and customize the core. The important thing is that as input, it takes a description of your custom instructions or some microarchitecture tweaks. So everything, either instruction or microarchitecture tweak, is described in a C-based language. We call the language Codel. It's architecture description language, so you can describe the instructions as well as their behavior and implementation. So there is a single description that describes the things that you would like to have there, and then the studio contains a set of generators. So you may generate RTL. It's readable, open, no encryption, no obfuscation. So you can just look at the RTL and go through that. It can be Verilog, System Verilog, VHDL. It's up to you. Then the SDK generation is obviously part of the studio. So we generate or customize LLVM-based toolchain. So Clang, these kind of tools are aware of changes that you might do. Like, they are aware of new instructions that you may add there. Obviously, low-level tools, assembler, disassembler, profiling tools, simulation tools. Every single tool that's inside of SDK is aware of your changes that you did inside of a code. Last but not least is verification environment. This is really important because verification really matters. So Studio comes with a UVM-based generator and test case generators and other helpers that are really useful for the verification. So that's part of it as well. And the verification environment really the purpose of that is really help you with the verification of your additional instructions, because the base one is verified by us already. So if you combine those two together, if you combine the BK core, RISC-V core that we already developed and verified with the Studio, that's kind of add-on to it, because it allows you to do customization and differentiation, and therefore differentiation. Then it's quite powerful because you may have a solution on the market that nobody has, and you can promote it quite easily. Such as kind of I have a RISC-V plus a couple of DSP instructions. I'm able to run this codec, and nobody else can. So that's the differentiation, and customers really care about that. And thanks to our solution, we can do it quite easily. So this is last slide related to the products and why we think that the differentiation and customization is important. And it's kind of tightly coupled to the next couple of slides that I put together. So again, kind of Zdenek's point of view on the open source hardware. So if you look at the good things or promises and hopes that are in there, then obviously it's really great for collaboration, because you can just find the code in the GitHub or whatever, and you can just say, hey, you just download that and use it inside of a chip because we did it and it's really good. It's also very good for reuse. So it may be the case that the fragmentation is lower, because if there is something that's verified and proven, that there is no need to create another one usually. So maybe the fragmentation may be lower because of that. It also helps with the with the development time, because you can just pick and choose whatever out there verified and connect it together thanks to the standard interfaces. It can really speed up the development thanks to the openness. The next thing is it's really useful for academia, because if you have some kind of research project and then you just use production-ready IP from some kind of library on the internet, and you can start doing your own research on top of that, instead of just spending time on licensing issues or legal issues, because you need something that's not free. So for the academia, it's definitely really important or good to have. But what about the industry? So this leads me to the challenges that we have inside of that domain. Because how do I check that the Git has everything I need, such as the documentation or some kind of test verification plans, things like that. Or if I'm stuck somewhere because something is missing, who do I call? Because is there a maintainer available for me, or it's gonna take a week or 2 weeks, a month until I get some answer. It may influence the schedule that I have, right? So this is something that it's really important to be aware of as well. Then things like the physical design issues like closing, time closure, synthesis scripts or EDA tools in general, the support for that. How the synthesis scripts is a chapter on its own. And so these are kind of generic, challenges that we either are facing or will face if we move forward. And I was talking about the customization and differentiation, so that's tied as well. So in the academia phase, it's really easy because it's open. You can change it, download it, whatever. But what if I would like to do some kind of real things, do I have to do verification by myself, or should I just ask the maintainer? Should I update the test plan somehow? These are open questions as well. And the hardware is one part, and what about the SDK part I was talking about? So I can take the RTL of RISC-V, I can modify it, but that's kind of the easiest part. But then I have to change all the binutils and the GCC and GDB to support that. In the world of processor, it's much more challenging. It's not just about the RTL, but also about the ecosystem. So then if there is nobody who can help you with that, it can be an issue because you have to invest your time into that. Which brings me to that slide, which is kind of my view on the possible solutions. So yeah, I was mentioning you can do it everything yourself, right? So, but you need to have some kind of knowledge how to do that. So if you add instructions into RISC-V, then you need to know how to patch GCC in a way that's able to use it. Otherwise, you will live just with the intrinsics or inline assembly, and that could be the case, but it's not that good. And if you need to maintain it for a longer time, it can be really burden because you have to maintain that changes somehow. And when there is a new release of GCC, you have to be sure that your changes are propagated properly. And because of that, I think that we have seen some changes there. So in the case of the shelf RISC-V, without any differentiation or customization, there are already companies or organizations that try to help you with that, such as Chip Alliance, Open Hardware, or Low Risk, that tries to give missing pieces like verification reports, documentations, these kind of things that you are used to in the industry that you have with your IP. So this part is okay because if I need off the shelf, I have everything I need. I have somebody to call. I have verification reports. I have pretty much everything. But the thing is that I cannot do customization, at least easily. I cannot do differentiation because this is something that companies may not be interested in. So then the last option I see is that just use tools such as our the studio that make life easier in this way. And the cost is definitely lower than do it yourself because you have a tool that does everything instead of just having experts on the GCC and the other tools. And you may therefore focus on other critical aspects inside of your project or whatever. The next thing is that the open source actually costs you something. I mean, in general, right? Because somebody has to pay for time. Either it's a university or a government or some kind of a company like you heard Google that provides some funding. So this is, from my point of view, is really we should be aware of that as well. I was mentioning the guys from Open Hardware and Low Risk and the Chip Island, so they are kind of supporters, so they need to maintain, they need to provide things that industry is used to. Yep. And last thing I'd like to mention is the automotive, which is chapter or its own. The thing is that the cycle is really long. I mean, you have to support the SDK and the product in general. You have to support it for a very long time. So who's going to be that maintainer? Is it going to be supporters, or is it going to be community? So there's going to be some university guys that will maintain something that's compliant with automotive standards. What about the other standards we have to have, like ISO 9001? So it's another chapter that is there, and again, this is not just about the RTL. RTL is just one part in this case, because in the case of automotive, you should have also compiled certified, but then you have to solve which version, who's going to maintain that version. So these are kind of open questions. I don't know answers to these questions, just trying to bring them up. So the last slide to keep the timeline is, from my point of view, it's it's the idea behind that is really nice. I'm really supportive, but there are open questions, and I think that we will see answers in near or further future how community or companies will target it. So that's a conclusion on the open hardware side, and on the our offering side. Just few things to remember. So we are providing RISC-V IP. So whenever or whoever is interested in RISC-V IP, just feel free to shoot me an email. And we have a program for the universities, which means that you can use the studio and BK for free if you want for research. So that's good to know. That's all I have. Yep. I think everybody is,
This is a philosophy question.
Okay.
So basically, there's a thing called commoditize or complement, which is that hardware guys want software to be free so they can sell more hardware, and software guys want hardware to be free so they can sell. So tool makers maybe benefit from free software. Some tool makers want to sell more tools, so they kind of restrict. Basically, where do you stand on that? Do you want to impose restrictions if someone uses the free version of your tools on the software they create, or?
Yeah, you're right. It's more a philosophical question, so I don't want to commit to anything. But yeah.
But for example, you said that at the end that the studio is free.
Well,
for academic.
Yeah. So we provide it because we see a value for the universities to see opportunities in the case of a customization. And also the students can learn about the tools and can learn how the processor works actually. And we are cooperating with some universities in the US, and their class is based on our tools, because they try to figure out how to extend RISC-V. And
do you restrict the license on the tools for which?
Yeah, I mean there is some kind of paperwork that needs to be done. So it's not like download it on GitHub. So we give it to you for free, but there has to be some kind of paperwork behind that.
Okay, but is it GPL, or can you have any license?
No, it's our paperwork.